left off in our packet? Remember, I had printed notes for you, Tyler, so you should.
Oh, the packet. Right.
Yeah, that's the homework that we're just going to add to today.
Okay, we have a packet.
You were actually with it and had your homework out for once.
I did. I just didn't have the packet.
Halfway there. Alright, so remember I told you when we were graphing or talking about our quadratics, and I told you the quadratic formula if you take the opposite of b over 2a portion, what did we use that to find? Gave us the axis of symmetry and the x value of our vertex. The second half of the quadratic formula is the discriminant, the b squared minus 4ac. My board's going to die. So when we are looking at that, it seems somewhat pointless, but it has a place. It tells us how many solutions we have to the quadratic equation. Which is how many x-intercepts we would get. So we know x-intercepts are when we draw the graph, how many times does it hit the x-axis. And you know with a parabola, there are several options. It could hit the x-axis 2 times. It could hit 1 time. Is it possible to never hit? Yeah. So those look differently when you graph them. We can tell without doing the entire quadratic formula just by looking at b squared minus 4ac. If that's a positive, then we have plus the square root of that number and minus the square root of that number. So that means we get 2 real solutions. In terms of our graph, that means there's 2 x-intercepts. It would be a graph that hit the x-axis twice. If it equals 0, then if you have maybe plus or minus the square root of 0, square root of 0 is 0 and it just turns into negative b over 2a. So if it equals 0, that's when you have 1 real solution. Or in terms of our graph, that means 1 x-intercept. And the final option, if it's a negative, if you have a negative under that square root, what kind of number are we getting? Imaginary. So that means we have 2 imaginary solutions. In terms of the graph, we can't graph the imaginary, so that means there are 0 x-intercepts. So it would be a graph that never hit the x-axis. Any questions about that? The final thing we're going to do with our quadratics is just talk about word problems. We said Friday that vertex is the maximum or minimum on our graph, so our highest or lowest point. And in terms of some scenarios where that might come up, one is vertical motion. We see this a lot in physics. S of t, so S of t is representing the height at a given point in time. T is your time in seconds. V sub 0 is your beginning velocity. H sub 0 is your beginning height. So you can fill that in. I think there's a box where you have to fill in the blank for some things on your notes. So let's look at this problem. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. So part A, give a function that describes the height of the ball in terms of time t. So we are using that equation. You wouldn't have to memorize this. If I were to give you this question on test or quiz, then I would put this formula probably in parentheses after it, but you just have to know enough to know how to use it. So S of t and t, those are variables like x and y. So we're just going to leave those. We basically have to plug in the v sub 0 and h sub 0. So v sub 0 beginning velocity was plus h sub 0, so that's your beginning height, which was, if you start on the ground, what would be your beginning height? 0. If something is going down, what would be true about your velocity? Negative. Velocity is just like speed with direction. So up is positive and down is negative.
So negative 16 is always going to stay.
That has to do with acceleration due to gravity. So that is a constant. All right, after how many seconds does the projectile reach its maximum height? So if I'm asking you about the maximum or minimum, what am I asking you to find? What am I asking you for here? If we're looking at this, what's the graph going to look like? An upside down parabola because of that t squared. So when I ask you for the maximum, that happens right here. What's another name for that point? The vertex. Okay, how do we find vertex? So the x in this case is replaced with a t, but same thing. Opposite of b over 2a. So it'd be negative 112 over 2 times negative 16. So 112 over 32. We get 3.5 seconds. What is the maximum height? What do we have to do there? Mm-hmm. 271 feet. Part C, this is the one where I meant to have use a calculator. Let's put it on the wrong part. For what interval of time is the height of the ball greater than 200? So I want everybody to get a graphing calculator here. This was my equation, and I want to know when that is greater than 200. So we could solve this by hand because we had quadratic inequalities on our last test, right? We know we'd have to bring over the 200 and then factor or figure out when it equals 0 and do our sign line. We can also use a graphing calculator for this. So on your calculator, you need to go to your y equals. Okay, I'm going to clear out anything that's there. So my y1, I'm going to do the negative 16, except you can't do t on here, so you have to do x squared. Plus 112x plus 75. And I'm going to go to my y2 and set that to 200. Now, if I just look at my normal viewing window, I can't really see much. So if we go to window, right now mine is set from negative 10 to 10. Did you get the equations under? So now if we go to window, we're trying to find out when it equals 200. So I'm going to make my y max something bigger than 200. So maybe I want to do 250. And then right underneath that, it says YSCL, or XSCL. That's what your calculator is counting by. So counting by ones, if I'm going all the way up to 250, might take a minute. I'm just going to count by tens to help speed up my calculator. The y's we may have to adjust. Let's just go ahead and look. So if we hit graph, okay, that doesn't really show me a whole lot, does it? Oh shoot, I messed up. I changed my x's. I meant to be changing my y's. Is there something wrong with your calculator?
It won't like show a graph.
Okay, I can fix that. It's because somebody has this step on. All right, let's just go zoom 6 and reset everything. I changed the wrong part on it. Now if you go to your window, you're welcome. I meant to be changing my y's because my height. So my y max is where I want my 250 to be. And my y scale, I'm going to do 10. And then we can look at a graph and see if we're seeing everything that we need. So I changed my y max to 250, y scale to 10. And then that shows me my graph. Okay, I'm trying to find when this is greater than 200. So when is this above 200? And we can see it's this little section is when our height is above 200. So what we have to do is find these points on our graph where they meet, and then we could say it's for everything in between them. We can do that on the calculator. If you go to second, and then the trace button, which is up here by the y equals, so second, trace. It gives you a menu of everything it can calculate. Which of those do you think I'm looking for? Maximum will give us the vertex. If I want to know where two things meet, we're actually looking for intersect, because I want to find where those were equal. Do you have a problem with it, Tyler? Is your calculator not working?
Seems like it,
Okay. So
I get any of this, I don't see it, but I get it.
Okay, you can't do the greater than 200 off here. What we did is we went to y2 and made that 200. So there's our parabola. There's the line. So we're trying to find where those meet. So we go to second, trace, intersect, number 5. Now, it's going to ask me questions. So you'll see at the bottom it says first curve. Your calculator will automatically do that, so all you have to do is hit enter. Right now you'll see my cursor's on my parabola. It's saying, is this the first graph? Hit enter. Second curve, it automatically moves to my line, so I just hit enter. Last thing, and this is the most important one. So these graphs go on forever. We're just looking at one section of it. We have to tell your calculator where to look, so it's asking for a guess. So we just use the arrows until we're reasonably close. Doesn't have to be super close. But if I hit enter, then it says intersection. So it is telling me they meet at this point. Okay, that's the first one, but we also need the second one. So we're going to go back and repeat that. So we can go second, trace, intersect again. First curve, we hit enter again. Second curve, we hit enter. Guess, this time we need to get closer to the second point and hit enter. And so that gives me the second intersection between them. So then when it's asking, when is it above 200, we can say between 1.39 seconds and 5.61 seconds. Do you guys see that? Okay. Did everybody get it to work on their calculator? We can do them by hand, it's just faster to do it on the calculator. So the last one wants to know, when will the ball hit the ground? If it hits the ground, what's our height? So we're asking for negative 16t squared plus 112t plus 75. When does that equal 0? And we have a couple ways of doing it. We can either work this out, so see if it factors nicely. If it doesn't, we could do quadratic formula or something like that. We could also use our calculator now that we know how to do that. Do you guys have a preference? Okay, so we're going to go to y equals. We already have the equation in y1. There's a couple ways to do it, but just so I'm not teaching you so much new stuff at one time, let's just go ahead and do y2 and set that to 0. And then we can do it the exact same way as the last one. So if I look at my graph, there's my parabola, this red down here, that's what I need to find. Now it hits 0 twice. Do I need both of those? No, because they are my times. And you can see this one would be a negative time, which isn't possible. And the reason being, we didn't start on the ground. We started up at this height, threw our ball up, and then it came back down. So we are looking for this point over here. So to get that, we can do the second trace intersect. First curve entered, second curve hit enter, but guess, make sure you go over close to that point and hit enter. And so we get 7.62 seconds for that one. Why don't you guys try this one? Do you have negative 16t squared plus 200t plus 50 for the equation? So to find the maximum height, that's the vertex. So negative 200 over 2 times negative 16. And you get 6.25. And then you plug that in. And what does that give us? So that's the maximum height. Okay, if you want to know when it's more than 300, so if we go to our y equals equation, negative 16x squared plus 200x plus 50, and we want 300. So if you're just looking at it originally, we can't see it, so we will have to adjust our window to go above that, so I'm going to make my y max 350 this time. Okay, and I'm only seeing part of it, so I need to adjust for my x's as well. So maybe I need to go up to, let's try 30 for the x max. So then I can see it. So then we do second trace intersect, first curve enter, second curve enter, guess. So my first point is 1.41. And the second one is 11.09. And then when does it hit the ground? So you have two options. We just need to know when this height is equal to 0. So you can solve it by hand or on the calculator by just changing your y2 to a 0. look at the graph. So we're finding those. We need the second one. So second, trace, intersect, enter, enter, and then that guess. So it's about 12.75 seconds. Are those okay? All right, so we are done. So add this to yesterday's, and we'll turn it all in tomorrow.